All right, now we're going to talk about how to find the excess reactant left over. So before you can determine how much excess is left over, you first need to determine which of your reactants is the limiting. So we've already done that in our example problem, but just remember if the question is just how much excess is left over, you first need to know, well, which reactant is my excess. So you have to find the limiting. Then you're going to set up a ratio. You're going to start with your limiting reactant, and you're going to use stoichiometry to convert into your excess reactant to see how much of the excess is needed. So just like we did when we were determining theoretical yield, when you went from grams of reactant to grams of product, you're going to do the same thing here. You're going to go from grams of limiting to grams of excess. Now that tells you how much is used or how much is needed. So then you just go back and subtract how much is needed from the original amount of excess, and that'll give you how much is left over. All right, so let's go back to our example. And we're going to look at question number 2. It says, how many grams of excess reagent remain unreacted? Well, we determined that copper 2 oxide is our limiting. So that must mean that ammonia is our excess reactant. So if you need to remind yourself of that, CuO is, I'm going to write LR for the limiting reactant. Ammonia is the excess reactant, the ER. So you're going to start with your limiting. I had 90.4 grams of copper 2 oxide. Before I go from copper 2 oxide to ammonia, I need this to be in moles. So you'll notice that this is the very first step I did up at the top, 79.55. Now I'm ready to set up my mole to mole ratio. So now ammonia is going to go on top. Copper 2 oxide is going to go on the bottom. And that ratio is 2 to 3. And now I'm going to convert this back into grams by putting the molar mass of ammonia on top. So that's 17.04. All right, so let's see what we get. Now, again, notice we're just setting up a gram to gram problem like you did on your recent quiz. Grams of your limiting to grams of your excess. So let's plug all that in. 90.4 divided by 79.55 times 2 divided by 3 times 17.04. I get 12.9 as my answer. Now that's not the answer to the question. That's just how much ammonia was used. So now I need to go back, look at my original amount of ammonia, and you'll notice that this number is less than 18.1. That's always a good thing to check for. When you get to this step, if you have a number bigger than that, you've done something wrong. So now I'm just going to subtract 18.1 minus 12.9. And I get 5.2 grams of ammonia remains. So that's the answer to question number 2. All right, so now going back to our PowerPoint, I already talked about this, determining the theoretical yield. This is just some definitions for you. What is the theoretical yield? It's the amount of product that should be formed. It's the maximum amount possible. So remember, that is determined by your limiting reactant. So we've already done this, but just to go through the steps, you find your limiting reactant, you convert your limiting reactant to the product using dimensional analysis. And like I said, you must start with the limiting. given to you in the problem. All right, so now we're going to move on to the very last concept, and that's how to calculate percent yield. So if we were in the lab and we were to do this experiment, we would produce an amount of nitrogen that would probably be less than the theoretical yield. That would be our actual yield. And that's just because of error. There's always error when we do labs. So your actual yield is typically less than the theoretical yield. And I would ask you to find the percent yield. So what you do, in the same way that anytime you find a percent, it's part over a whole, you just take the actual yield, divide by the theoretical, and then you multiply by 100. So remember, the actual yield is what you really get in the lab. The theoretical yield is what you should get based on your math, and then multiply by 100 to get your percent. Okay, so let's look. This last concept is pretty easy. So it says to calculate the percent yield if 8.1 grams of nitrogen is formed. They're telling you that you're in the lab and this is how much you actually produced. So this is your actual yield. So to find the percent yield, you take actual over theoretical times 100. So the actual yield is 8.1. The theoretical yield is 10.6. So I just need to divide those two and multiply by 100. And I get 76.4%. So, which if we were doing a lab, that wouldn't be a terrible number, but we would want to get as close to 100% as possible. So these are your notes on how to do limiting reagents. I would encourage you now to go back through these two videos and attempt this next problem on your own. I'm going to post another video where I am working through this problem with you. But like I said, I think you should try it first on your own before you watch that video. And guys, I'll go ahead and tell you, this is not an easy topic. Stoichiometry, especially where we are now in this unit, is one of the more challenging concepts in chemistry. So if you are having trouble, try not to get too frustrated. Just let me know. We can video chat. I can walk you through some problems. But just know that this is not an easy thing. So you're not alone. All right, good luck.